creating that top edge, right? That top part of the surface, or part of the solid. And then what's the bottom of this solid? It's the xy plane, right? The xy plane is the bottom. The xy plane is z equals 0. So it's kind of like that tilted plane is the top, z equals 0 is the bottom. Understand? We want the volume between those two. Now you need to look at what's the region that I have to integrate over. And that's where you have to take this thing. Let me pull this thing out again. Let's take this thing, and there it was. There was my picture. If we just look at it from the top, remember where the x-axis is. Whoa, what are you doing, man? Okay, right about there. Where is it? 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 Come on. Never understood this. Sorry, there's a thing, it's supposed to switch over to a different icon so I can rotate this thing. All right, doesn't look like it's happening. It's not wanting to behave. Ah! Oh, wow. Okay, there it is. No, I'm just kidding. So this is the x-axis. This is the y-axis. This is that, if you were to like cast a shadow straight down, that's your region. All right? I don't know. Does that work or not? I'm having trouble with this damn thing over here. Do y'all see that that's the region on the ground? Okay, so let's try and actually come up with what that is. So what is the f of xy? Let's start with that. What's the surface on top? It's given to us by this plane, right? So you must solve this for z to turn it into a function of x and y. So if I solve this for z, I get 2 minus x minus 2y, and that's it, right? So that's your top. What is the bottom surface? 0, right? So I don't need to write it, but I just want to be clear that there is a bottom to this. The bottom is 0. And how do you find the volume between two surfaces? Subtract them. So I'm really going to be doing this minus 0, which is just this. Understand? Now, the region. The region we got, here's x, here's y. We had that one diagonal coming through here. It was y is 1/2 x. And then there was another one coming through here. Wasn't there? It's where that plane came down, it's where this surface came down and hit our plane. How do I find that? How do I find where this surface right here hits our plane? Hits the xy plane. Replace z with 0. Right? If I want to know where this plane right here came down and cut through and made this edge, I need to actually figure out when that plane equation was equal to, when the z coordinate was 0. So I just go back up to this, I replace z with 0. What happens if I replace this with 0? Z with 0. X plus 2y equals 2. And I can solve this for y. I don't know. X plus 2y equals 2. I can solve this for I'm going to do it for y. Because I can look at this. It's going to be a type 1 region. So I'm going to solve for y. Negative x plus 2, divide by 2, negative 1/2 x plus 1. And if you were asked to graph that, you would go up 1, dot, and then you would draw a line, and they're going to hit each other somewhere. This is y equals negative 1/2 x plus 1. What do you think? It's a little bit more involved when you're just not like given all the stuff straightforward. The region isn't just defined. You have to go find the region. There's a little bit more thinking involved. All right, type 1, type 2. What do you think? We can do this type 1. You could do a type 2, but you would have to split it into 2 separate ones, which we haven't talked about doing. So this is a type 1, because as I draw these verticals like this, I'm always stuck between 2 functions of x, and my x coordinates are always stuck between 2 constants. And this one right here we could find by setting these equal to each other, and I'll trust that you could get that that's 1. I stopped using colors. So what is our double integral? Because I think we're ready for it. So type 1, so we're going to go restrictions on x first. 0 to 1. And then y is the bottom one, 1/2 x. Top one,
Negative 1/2 x.
negative 1/2 x plus 1. What am I integrating? That solved for z, so 2 minus x minus 2y. And I'm going with respect to y and then respect to x. There it is. There's the setup. There will be problems on your final exam where I just ask you for the setup, because there's just not time to make you go through the whole thing. All right? Because I need to ask you other questions too. But on your homework, which I know all of you are doing all your homework, was that sarcastic? Did that seem sarcastic? Okay. Didn't mean to. On your homework, take them the whole way. Practice that computation. All right, moving along. Order might matter. Okay, let's set this one up. Let's do this one. Integral from 0 to 1, x to 1, sine y squared dy dx. So this one I just give it to you, and there's no, I'm not asking you to do anything other than just evaluate this. Okay, go ahead. What's the antiderivative of sine of y squared? That's the first part we have to do, right? Integral 0 to 1. We're going to take that antiderivative. We're going to go dx, right? So antiderivative of this.
Negative cosine y squared. Negative 1/2 cosine.
Negative 2y.
Let's cheat. Let's cheat. Let's go to Wolfram alpha. Integrate, what is it? Sine y squared. Oh, you're going to love this. You're going to love this.
Can't forget the constant.
The answer is square root of pi over 2, then capital S of square root of 2 over pi y, where capital S is the Frenzel S integral, which of course we all know what the Frenzel S integral is, right? No. This basically means no go, okay? It's not integrable. Just like in Cal 2, hopefully your professor showed you there are some functions you just cannot integrate, which is what makes power series so cool, because you could do a power series expansion, which I'm sure if I scroll down, Wolfram alpha would have done the series expansion, and then you could integrate that, because you could integrate that. So, I mean, if you use series, you can get approximations, all right? If you use series. The whole point of this problem is to make you appreciate the fact that, hey, look, sometimes the integral isn't possible to do. However, let's take a look at the region. What is this region? Let's draw it. So this is a question like, uh-oh, I'm in trouble, right?
So isn't x just
So what does this mean? The outer integral is x, right? So that means this is a type 1 region, which means your x's are between 0 and 1, and your y's are between x and 1. So this is really saying like y equals x and y equals 1, right? Let's draw that over here. Y equals 1 is a constant function like this, right? That's y equals 1. Y equals x looks like this. Agreed? This was y equals 1. And x was between 0 and 1, which would be here and here. So they were talking about that region, weren't they? Yes? Which is a type 1 region, isn't it? It is? But is it a type 2 region? Yes, it's also a type 2 region. What would happen if I reset this integral up as a type 2? The only difference would be, let's see, what would be my restriction on the y values? 0 to 1. But now the restriction on the x's. That means you take each of these and use, well, I have to look at where's my boundary here? I'm between these two, right, the whole time? What is this one? X equals y, right? Y equals x, but we're solving it for x this time. So x equals y, so I'm going to put here, what?
X equals 1.
Yes. How about I just put y so that there's no confusion? Right? This is when we go this way, it's a function of y, isn't it? I could put x equals y, but just to stress that it's a function of y, I'm putting y. So that's why. Why did I put it down there? I should not have put it down there. Sorry, it's up here. What goes down here? This bottom one right here, which is always 0. So y equals 0. Our y's go between 0 and y, right? 0 and y. This is the identity. And then I'm going to do what? Sine of y squared dx dy, and that's the savior right there. That's the savior. Because look, do y'all see how that's going to save us? If I ask you to integrate this with respect to x, well, this is all in terms of y. This is just a constant then, right? So look at what happens. So I'm going to take this right here. Integral 0 to 1. And then we have sine y squared x evaluated from what? X equals 0 to x equals y. See, that's why I didn't want to put x equals 0 and x equals y here, because I wanted you to understand this has to be a function of y. I don't know if that confused you more, but. And then I'm going to integrate that with respect to y when I'm done. So let's plug in, let's replace x with y. What happens if we replace x with y? We just get this times y, right? What happens if we replace x with 0? We get 0. So all that's really there is y sine y squared dy. You can integrate this. This is just a basic u sub. Because now we have this y out here, don't we? So the derivative of y squared is 2y, so we have it. That wasn't there earlier. So what would the antiderivative of that be? 1/2 negative cosine y squared. Let's just check it. Derivative cosine of y squared would be negative sine of y squared times 2y, and that would cancel, and you'd get back this. Now I still have to evaluate from 0 to 1, right? And if we plug in 1, we get negative 1/2 cosine 1 minus, if we plug in 0, what's cosine of 0? 1, so minus 1/2. Minus 1/2, right? Plus 1/2. See, we beat Wolfram Alpha there. It's one of the rare times we win. the order matters sometimes. If you switch the order of integration, so if you were going to try and summarize for me what is required to change the order of integration, what do you have to do? If I give you that and say change the order of integration, what do you have to do?
Change that.
Yeah, but how? Like, what are you actually going to do? Like, draw it, right? You're going to have to draw the region to start. Once you draw the region, you switch it, and then you go back and redo the integral. All right. Order might matter. What did Wolfram alpha ever come up with that
No.
at all?
I don't think it came up with Z.
I don't,
Didn't come close.
it did some definite integrals and got some answers. Yeah, well,
Well, wouldn't you have to integrate?
yeah, we'd have to integrate again. I'm just wondering if it never got a general solution. Not in a nice closed form. Next thing. All right, here's what we were talking about earlier. If you have a region D that is the union of two other regions, D1 and D2. So if this big capital D, this red ugly region, is made up of two separate regions, then you can split the integral over D into the integral over D1 plus the integral over D2. That seems straightforward to you? I mean, that's just like when we had an integral on a number line between two numbers. You could just go like part of the way and then add to it going the rest of the way. All right, this is super important right here. And as much as I try and stress this to my classes, this always seems to just get by. I don't know why. So what I'm going to do is I'm going to say it, and then I'm going to come over and I'm going to hit each of you in the head with a stick, and that way you remember it. Okay? I've heard that. I think that's very effective. Yes? The double integral as the area of D. If your surface is the constant one function. Okay? So imagine we have a region on the floor, right? Some region. And the surface above it is just flat. Okay? Flat. Then if we find the volume below it, the answer is the area of D. What? I hope that makes sense, but I'll draw it. See, everyone shakes their head and says, yeah, I got it. And then again, they forget it later. So let me just make sure. You've got some region D on the ground. There's D. You have some surface that's sitting above this, right? And that surface is sitting how high above it? 1 the whole time. It's the constant 1 function. I'm going to exaggerate it. I'm going to put it up here like this. Okay, that's the surface above it. And it's always 1 unit high. 1, always. The volume of this solid is equal to the area of this times how tall it is, right? But how tall is it? 1. So the volume is equivalent to the area. Because this is a 1, you multiply that height, you always get the same number as you would get from the area. It has to be f of xy equals 1. So let me try and illustrate how we can use this. Whoa. No, it's not that one. Okay. I know this is going to seem completely trivial, but I just want to show that it works, okay? It is going to seem trivial. Okay, here we have, let's see here, 2, triangle right here. See that triangle? What's its area? 1/2 base times height, right? So the area would be 2, okay? Now, I'm going to find that area using a double integral. Just to show you it works. I know that that seems like absurdity, but later on, trust me, we can actually prove some very nice formulas later, like the area of a circle is pi r squared. Does anyone remember from my Cal 2 class how I proved that? It was really nice, but it required doing trigonometric substitution and some other things. I'm going to be able to prove area of a circle is pi r squared. It's going to take about 30 seconds to do it in a little while. Not yet, but it uses this formula that I'm trying to illustrate. Okay, not the triangle. It's just that the double integral over the constant 1 function is the area. So what I'm going to do is I need to write that region. Is that, I can look at that as type 1? Yes, type 1. If I do a type 1, then I need an upper and a lower bound function. The lower bound function is 0, isn't it? What's the upper bound one? What's the equation of that line? Y equals negative x plus 2. Agreed? Yeah? And so I should just set up double integral 0 to 2, 0 to negative x plus 2, right? What is the function that I'm going to integrate if I'm trying to find the area of that region? 1. I'm just going to put 1 here. All right? And then well, dA, but because this is a type 1, it's y dx, right? Because it's a type 1. All right, let's try this. Keep going. What's the antiderivative of 1 with respect to y? Just y. And where am I evaluating y? 0 and negative x plus 2. Now, what happens when you plug in negative x plus 2 for that? You just get negative x plus 2. What happens when you plug in 0 for that? You get 0. So this is just integral from 0 to 2 of negative x plus 2 with respect to x. What's the antiderivative of that? Negative 1/2 x squared plus 2x. Evaluate it from 0 to 2. What happens when I plug in 0? Because that's the easy one. It's gone. What happens when I plug in 2? I get what? Negative 2, right? This will be 4, half of that. Negative 2 plus 4, that's equal to 2. That's not a coincidence that those are the same answer. You would never, ever do that to find the area of a triangle. That's just to verify that it works. And just because it worked once doesn't mean it always works. I'm just trying to convince you that, hey, it does. You have to believe me. What do you integrate? If you want to find the area of the region D, what function do you integrate? What's your f of x, y? 1. Yes?
So would that work for any, like, let's say instead of it being 1 unit up, if it'll say unit 500 up, and then it's just the area times 500?
That would be 500 times the area, yeah. Which you really wouldn't need that, but because if you had 500, you just pull it out of the integral, and then it'd be the area, and then times 500.
And that's the volume of the surface.
The volume of that solid is equivalent to the area, but only because the height of the surface is always 1. And when we move into triple integrals, which is coming up, our region of integration is going to be 3-dimensional. And if we integrate the constant 1 function, we can find the volume of the region. It's where we're going, all right? That's what we'll do. Next class, we're going to do a quiz. And what I'll do is I'll come in here and I'm going to pick one person. And I'm going to be like, what's the function that you integrate in order to find the area of the region D for a double integral? And if they answer 1, everyone gets 100. And if they answer 0, then I'm going to go around. Everyone's going to suffer. I'm going to smack everyone with this yardstick, okay? I'm going to use this edge too. I'm not going to turn it flat. I'm going to turn it to that edge instead of that one. Okay? No holes. No holes. No, this is plenty right there.
Will that quiz be at the beginning of class?
We'll do it. Let's do it at the end in case I hurt someone real bad. That way we can just call it a week, and you have the whole weekend to recover. Now, I'm not going to give you all a quiz, but please remember that, okay?
Oh, that would have been
All right, we've got 15 minutes. I think that's enough time to do the
signage.
sign-in sheet. Yeah. There's some problems in the book that I wanted to look at and do in class, and number 28 looks like an interesting one. Can you all see it? The instructions here are to find the volume of the solid that is bounded by the cylinder y squared plus z squared equals 4, the planes x equals 2y, x equals 0, z equals 0 in the first octant. All right. I'm going to have to jot that down. Y squared plus z squared equals 4. The planes x equals 2y, x equals 0, z equals 0 in octant 1. Find the volume of the solid that's bounded by all those. That's the homework up there, but I'm going to work this one out. Octant 1 is what? Everything's positive, yep. All right, let's do it. I'm just going to start drawing some pictures because I need to get an idea of what this thing looks like, and it's somewhat complicated, all right? What is the first? Maybe I'll do it this way. X this way, Y this way, Z this way. Hope for the best. I'm not arbitrarily labeling those, right? I'm always following the right-hand rule when I do those axes?
Yes.
All right. All right, what does this look like? Or what is this? Cylinder
Free in the x-axis.
going down the x-axis, radius 2. Okay, so I've got, let me try and draw it. This guy right here is a cylinder going down the x-axis like this. This is just a rough sketch. I want to get an idea of what's happening. Okay. How about x equals 0? Let's do that one next because it seems pretty straightforward. X is 0 is the YZ plane. That's the back wall, isn't it? So that actually cuts my cylinder off back there, doesn't it? It like cuts my cylinder in the back. So I can actually take that back off probably. Yes? And then what about Z equals 0? That's the XY plane. That means I can take the bottom of it off, right? And then what does the first octant mean?
It's in the first quadrant.
It's almost like the XZ plane is cutting it off too. Yeah? Okay, I want to redraw it because now I have a better idea of what I'm looking at.
Yes.
It's like a what?
Like a little chocolate bar. Like one of those
Chocolate bar?
Those weird ones from like England or whatever. I forgot what they're called. Like a peach cobbler or whatever.
Okay, so let me see here. Try and be a little better with this. I've got something that looks like this. Something that looks more like that.
Yeah, there's good.
Thank you. It looks kind of elliptic-y to me, though. It doesn't look like a circle.
Well, you also
I'm a little unhappy with how tall that is compared to that, but I can live with it.
You have another plane.
Yeah, now I've conveniently left out one plane, and that's this one right here. And if you solve that for y, isn't that same one from earlier, y equals 1/2 x?
Yes.
And that would cut through, and it would just do like, it would just slice through this thing, wouldn't it? Yeah? At an angle. So it's kind of slicing like this. Like here it comes through, right? Man, I shouldn't have put that angle on it because it's going to be hard for me to draw it. Let's exaggerate. It's coming through like that, let's say. Now it's a plane, right? Okay. So can you see how that would cut our solid? You would actually have something that looks like this. That's where that plane would slice that. It would go back to the origin. It would go up. It would be bounded on the backside, bounded by the cylinder and over there like that. That's our picture. That's the solid. Can you tell me about the top surface there? That top surface is the cylinder, isn't it? And can you take that equation of the cylinder and write it as a function of x and y?
Yes.
Yes, what would it be? What?
Like y squared minus
Square root of 4 minus y squared. You're solving this for z, right? Remember when we had the plane in the previous problem and we solved it for z? Same thing here. This is the top surface. What's the bottom of this solid? 0, right? The xy plane. So z equals 0 is the bottom. And then what would the shadow on the ground, what does that look like? It's this piece right here. Isn't that our domain? That's our domain. And I can try and draw that in two-dimensional space. This was our x, this was our y. So doesn't it kind of look like this? That's it, like that?
Yeah.
Do you know how tall this one is? Do you know how high that is? 2, because it comes from the radius of the cylinder. Do you know, so this I could look at it as being y is 2. What about this? That's y is 1/2 x. Do you know how far, because this is a type 1 region, do you know how far it goes? Do you know your restrictions on x?
4.
Should go out to 4. Because you would have to set these two equal to each other. 2 equals half of x, solve for x, get x is 4. Do we have everything we need?
Yes.
We should. We've got our type 1 region, we've got our limits, we've got our function we're integrating. Set it up. So it's going to look like, go from 0 to 4 on the x, and then from where to where on the y?
So 1/2 x
The bottom one is always 1/2 x.
to 2.
The top one is a constant function, 2. Right? It's always stuck between 1/2 x and 2. And then our function we're integrating, square root 4 minus y squared, dy dx. And then you're off to the races. That's probably to integrate that, you either use a formula in the back of the book or good old trigonometric substitution. Trig sub, Cal 2. Now, I just led you through that whole problem, which, I knew what to draw and I felt comfortable with it. This is where it's going to be challenging for you, is because you're going to have it, you're going to be like trying to draw it, and you got to convince yourself that your picture's right. Yeah? Make sure you feel good about it. So,
Now, could you take this equation and do it the other way?
as a type
2
2, yes, you could do a type 2.
with the same.
What would change here is that you would go from 0 to 2 on y, right? 0 to 2. And then here, it would go from here to here. So you would go from 0 to, you'd have to solve this for x. 0 to 2y. And then you would do the same integral, but it would be with respect to x first, then y. Which might be better, because if you integrate that with respect to x, it's going to be easier. Should be.
Well, that's what I was
Yeah.
saying.
Yeah. Everyone got the homework? Is anybody not here? Everyone's here? Okay. Have a good weekend. Do your homework, but then also do your mini exam.
Oh, there's a quiz.
And don't forget the quiz.